Hi, grade 11s. Today we'll be looking at mixed trig functions, meaning that you are given two functions or more and you've got questions to answer based on those two functions. Let's look at how some of the examples are asked. Let's look at example 1. It says here, on the grid below, sketch the graph of f at x equals minus 2 cos x and g at x equals sine 2x. For the interval negative 90 degrees less or equals to x less than 180 degrees on the same system of axes. So this is where we're going to draw these two graphs. We know that you've got to take your calculator and then you can plug in that. So for this function here, so you go to mode and then you go to table, which is 7, and then f at x will give you, so it's a minus 2, we say is cos of x, so we're going to use that x, not the times the x there, so it's alpha the x, then you close, gives you an answer. Now this gives you something else, it's another function, we are not interested in that, so I go equal sign to continue and then say start. We are starting at minus 90, so I must enter negative 90 degrees, then equal to, and we stop at 180 degrees, then I enter 180 degrees, and then the steps, you can see that these things here, the steps are 45 degrees, from 45, from 45 to 90 is 45, from there to there is 45, so the steps are 45. Okay, so I can enter the points here. So the first point that I get is minus 90 is to 0, put it over here, minus 90 is to 0 is there at the point there. Then the next point is minus 45 is minus 1,4, so it's minus 1,4 is there, and then at 0 I go to minus 2, so I go there, and then find the next point. It's 45 to minus 1,4, and then the next one is 90 is to 0, and then the next point 135 to 1.4 somewhere there, and then the next one is 180 to 2, and then you can join these points by freehand, no ruler, remember. So you do that. You can use a pencil so in case you make a mistake, it'll be easier for you to like erase the mistakes. So there we go. And then this graph of ours is the graph of f, so this is graph of f. It's also important that you label the important points for extra marks. So this is 180 degrees is to 2, and then I suppose this given point, and then there's a given point, and there's a given point. So that's a graph of f. Now the next one is to draw the graph of g at x equals to sine 2x. So we go back to our function there. So now instead of using g at x, can you still use f at x? Okay, so then this is sine 2x now. So I'll go sine, then I plug in 2, then alpha there, and x, then I close. So that's a graph, and then we say, forget about the next g at x there. So we start at minus 90, and then we said we added 180, we ended 180, and then the steps, we said the steps here were 45 degrees, and then here the values. So the first point is minus 90 to 0, is same as the previous one. Minus 45 to minus 1 is that point over there. This one 0 is to 0 is a point over there. Then the next point, 45 to 1 is a point over there. Then the next point is 90 is to 0, which is there, and then the other one 135 to minus 1 is over there, and the last one is 180 is to 0 is a point over there. So to join the points here, starting from the first one, it goes there, then to 10, cuts there, turns over there, and then turns and cuts there, and then turns down and stop there. So this is a new graph now, the graph of g. So I can say this is a graph of g, and the point there is 45 degrees is to 1, and this one here is minus 45 degrees is to minus 1. Okay, now there are some questions that are based on this graph. Here's a question. Now use the graph, you've got to use your graph, whether it's right or wrong, use your graph to find the values of x, where g at x minus f at x equals to. G at x is the top graph, you subtract the bottom graph, the units are 2. Where is it? Where the graph of g is on top. Graph of g is the blue one, where is it on top? Subtract the bottom one, get 2 units. Check distance from there to there, that's 2 units. From that's 1 unit, 2 unit. So that's the distance there, is 2 units. What is the value of x there? the x is 0 here. X is 0. Is there another point where this distance is 2? No, that is more than 2. This is only where we've got 2. So when x is 0, so the answer here, we find that the answer is x equals 0 degrees. Next one says, where is f of x? Now the graph of f is less than g at x. It means that where is this graph? Below. So this symbol here, sometimes you say it means below. Where is it below? Where is the graph of f? Below. The graph of f, remember, is the red. Where is the graph of the red graph? You can see f is the red graph. Where is this one here? Below the blue one. Below. So where is it below? Where is the red below? You can see it's below here. It's all below the blue. The blue is above. Below, 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 until we reach this stage. The red is below until we reach there. So the x value start from minus 90 degrees until we reach 90 degrees. So our answer here is x is an element of, we start from minus 90 degrees and we said we stop at 90 degrees. Next one says, where is f of x, right? F of x, which said is red. When you multiply it with the g of x, which is the blue graph, the answer is greater than 0. Another interpretation of this, when it says greater than 0, it means where is the product of this? Greater than 0, anything that's greater than 0 is positive. Where is it positive? When I multiply these graphs, I get positive. Remember that when I multiply things that have got the same signs, we get a positive answer. So it means that it's where the two graphs are either above the x-axis or below the x-axis. Check here, both of them. You can see here from here up to here, both of them are below. But after this, now it changes because that is above the x-axis and this one is below the x-axis. So they want where it is are the two graphs at the same time, below or above. It's only this area. So you can say from minus 90 degrees to 0 degrees. But you are not going to include the minus 90 and 0 because there is no equal sign here. So the answer here will say x is an element of this round bracket minus 90 degrees until we reach 0 degrees round bracket again. Now next one, where is f of x and g at x are both increasing? Meaning when you draw the graphs, you increase, you go up for both of them at the same time. You can see here when I draw these graphs here, I'm going down, 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 down. But this one now I go up, but this one's still going up. Now it's going up, this one going down. But it's here, then both of them, they go up, 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 up. Then this one goes down. So this area here, they're both going up. This come here, this going down, 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 down. But this one here, but at this point here, then both of them, they go up. So we've got these two parts, this one here and this part over here, where they're both increasing. So the answer here will be they're both increasing from 0 to 45 degrees. So x is an element of from 0 degrees to 45 degrees. But we've got to exclude 45 degrees because this one is turning at 45 degrees. Also here, this one is turning, so it must be a round bracket there. So union somewhere else, we said also here from 135 to 180 degrees, 135 degrees to 180 degrees, exclude 180 degrees. Now if f of x is reflected in the x-axis and move 30 degrees right to form a new graph h at x, give the equation of this new graph. So we take the graph of f, we reflect it in the x-axis and move it 30 degrees to the right. Okay, so when you reflect the graph of f, what happens? The graph, the sign of graph of f changes. So therefore we can say the graph that they are looking for is h at x equals, you've got to change because you are reflecting, you're changing the sign of y. So you change the sign of this, becomes negative f of x. Then you move 30 degrees to the right. So if you move 30 degrees to the right, you say minus 30 degrees. So it's x minus 30 degrees. So it's like that. You change the sign of f and then you can write it like that. Some people will write it like this. Also, they can write it like this. So say h of x is equal to, take the graph, that is equation was given. It's a graph of f. You change the sign there. Now instead it's negative, so it becomes positive. It that will be equal to positive 2 of cos of x. Now you move it 30 degrees to the right, then we say minus 30 degrees. So both answers will be correct. Let's look at another example that you can get. In some cases, they give you just a graph being drawn for you like this. So the graph of g, which is sine x, and the graph of h, which is b tan x or something. And then they say in this interval that is given, right, is f and g, they intersected these 2 points that's given. Then there'll be questions. So what I usually do is that when you get the 2 graphs, immediately just highlight them so that you can see the difference between them. You can see the dotted line here. If I do the dotted line here, that's a 10 graph that has got the dotted line. And you must remember what we call the dotted lines. They are called the asymptotes of the graph. Okay, and this graph, which is red, now is a graph going like that. And you can see it's a 10 graph. It's like that, going down like that. And this one here is this graph here going up to here. Right, so this is a graph of h. They put h there, so because the arms are different. Now let's look at the other one, which is the graph of g. G is this one here. If I use a green line, like a green pen, let's do like this. There's a graph, goes up all the way and then all the way up to there, and this is a graph of g. Okay, now let's look at what the questions are based on this one here. Here are the questions. They say here, write down the values of a, b, and c. You can see that a is from the sine graph. This like this means that the graph of sine has been shifted either right or left. If you look at the sine graph here, it's supposed to start here but shifted to the left, 45 degrees to the left. Therefore, to answer this question, to find what's the value of a, it means that a is equal to 45 degrees. You can say a is 45 degrees. Now, b is found on the graph of 10. The 10 graph, remember that it goes up like this. Now this one is coming like this. So what has happened to the graph of 10? Is either you can say the graph of 10 now is negative, right? So it means that the sign here is changing. So it means that the b value is equal to -1 because it also go up to 1 unit. Next one, to find c. C is about the amplitude. You can see it's about the period of the graph. This graph here is still 180 degrees. Nothing has changed. So it means that the b value of this graph here from the original 10 graph is the same as 1. So c is equal to 1. So the c value is equal to 1. Okay, let's look at another question. Write down the equation of the asymptote of the graph of h. The asymptote are the dotted lines. So what is the equation? The equation on a given answer must say x is equal to something, right? That's an equation. So it's an equation here, x is equal to -90. It's -90 degrees. The other one is this one here, which x is equal to 90 degrees. It's x is equal to 90 degrees. Here's another question. Solve for x if h of g at x minus h at x is greater or equal to 0. There are no other numbers. I can take this to the other side to make things easier for myself. So if I write g of x is greater or equals to h of x, now it means where is this graph of g above the graph of h? The graph of g, remember, is the green graph, right? Above the graph of h. The graph of h is the red. So where is the green graph? Above the graph of h, above the red one. Where is it above? But from -180 to 0. From -180 to 0. Where is the graph of g above? Where is the green above? You can see here it's below. But from here it's above. But we don't know the asymptotes because after that the green graph is below. So we can say it is above from -135 degrees until we reach -90 degrees, but we've got to exclude that. So we can say the answer is x in an element of from -135 degrees until we get -90 degrees union. Also, is there another position where this graph is above? Yes, because they said from this to 0 here in this small space here, and the x field is -22,3 degrees, and then we get 0. So here, so we say union from here at -22,3 degrees until we get 0 degrees there. So we stop there, we can close over there. So that's 4 marks. Now let's see how they can ask you in the exams. So the exams from your textbook, chapter 5, 5.7, exercise 5.32, and see how you can do those ones there.